All right, welcome. We're going to finish the section 4.1 on introducing hypothesis testing. So right now, if you're looking at this at home, it might be worth grabbing a piece of paper and take a minute or two to write down the hypothesis for each of the following situations. Does the proportion of people who support gun control differ between males and females? Is the average hours of sleep per night for college students less than 7? All right, if you want to try this for yourself, I'll go ahead and click pause because I'm going to go through these right now. So for the first one, the proportion of people who support gun control between males and females, you'd first want to note down your variables. So P subscript F would be the proportion of females who support gun control, and P subscript M would be the proportion of males who support gun control. So we have our variables defined, P subscript F, P subscript M, both population parameters. Then the null hypothesis would be that we assume that there's no difference, or that the proportion of females is equal to the proportion of males who support gun control. And the alternative is that there is a difference and not equal to. And that comes from the wording. Does the proportion of people who support gun control differ? We're not saying is it more or less between the male or females, just does it differ. For the second one, we're going to look at the average number of hours of sleep per night for the college student. So we're going to let mu denote the average hours of sleep per night for college student. So mu is an average, but average can mean a lot of different things. So make sure to clearly state what your variables mean. Average number of sleep for a college student. The null hypothesis is that students do sleep 7 hours per night, and we got that 7 from the statement. But we want to know, do students sleep less than 7? So the alternative is that students sleep less than 7 hours of sleep per night. And again, the evidence, if you're to do a study or a sample, the evidence should support the alternative hypothesis. All right, so if we were meeting in class, I'd have you guys come up with a situation where you want to establish a claim based on data. What parameters are you interested in? And what would be the null on alternative hypothesis? And then what type of data would lead you to believe the null hypothesis is probably not true? So since this is a hybrid or possibly online class, we're not going to go through this right now. But we are going to go through this in terms of the group project or possibly some online content. Okay, so evidence. The goal of hypothesis test is to determine whether the sample data provide enough evidence to refute the null hypothesis in favor of the alternative. The evidence should always support the alternative, but does it support it enough? So let's go back to the ESP example with the 5 playing cards that you're trying to guess. The alternative, or the null hypothesis, is that P is 1/5. The alternative is P is greater than 1/5, because you assume that you could telepathically communicate the card to your partner. So which P hat, which sample proportion would give the strongest evidence against the null and in favor of the alternative out of these 5 options? And that would be E. We're looking at the P hat that is most supportive of the alternative. 1/2 is greater than 1/5. And out of these 5 options, it is the greatest value, more than 1/5. So it'd be the strongest evidence against the null and in favor of the alternative hypothesis. So with the same scenario, P equals 1/5, P greater than 1/5 for the null alternative. Discuss the following in terms of evidence against the null and in favor of the alternative hypothesis. Suppose you did a sample with these 5 playing cards, and you or your partner got 1/6 of the cards correct. In this case, this would be no evidence against H0 or in favor of the alternative HA, because 1/6 is actually less than 1/5. If you or your partner guessed exactly 1/5 correct, then that would be, again, no evidence against the null, because that's exactly equal to 1/5. If you got 1/4 of them correct, say you're doing 20 of them and you got 5 right instead of 4, which would be the null hypothesis, that would be some evidence against the null and in favor of the alternative, but is it enough? Maybe you might want to argue that you or your partner just got kind of lucky and guessed right a couple more times than normal. And if you or your partner guessed 1/3 of the cards correct, well, there'd be stronger evidence against the null hypothesis, and that would favor the alternative. But again, there's that question again, is it enough evidence, or is someone just going to say you got lucky? You don't have ESP. So how high does p hat have to be to say ESP exists? Well, that is coming up. We're going to talk about that in later sections in Chapter 4, and actually throughout the rest of the semester. We'll kind of talk about this question. How do we measure the strength of evidence against the null and in favor of the alternative? So we'll talk about that in 4.2, and how do we know whether or not we have enough evidence to reject H0 in favor of HA? That'll be in 4.3, and we'll talk about that in 4.4 also. So in summary, we talked about statistical tests use data from a sample to assess claim about a population. The population is usually too big to just ask everyone or do a complete census. Statistical tests are usually formalized with competing hypotheses. A null hypothesis vaguely mean there's no effect or no difference, and the null hypothesis should always be a statement of equality. The alternative hypothesis is what we seek evidence for, and this should be a less than, greater than, or not equal to statement. An hypothesis test examines whether sample data provide enough evidence to refute the null and support the alternative, and we'll talk about what we mean by enough evidence in the next 2 sections. All right, thank you.